Hello everybody, Chris here, and in this video I'm going to be showing all of you how to use my Grid Builder plugin for Godot 4. So this is starting from version 1.0.2 for this long form tutorial. And if you haven't already, you can find the plugin on itch.io and my Ko-Fi and Patreon pages as well. So if you download the plugin, the first thing to do is going to be to put the contents inside of add-ons/grid building. Most Godot plugins will go in the add-ons folder. So inside of grid building, there are many classes that are defined with a class name, and that allows you to see them when you are creating new nodes for your scenes. But in order for that to work, you need to go to project settings, and then for plugins, just check grid building enabled. So you should see this if you installed it right. And once you've done that, if you go to other nodes, we could search for things like building system, and we'd be able to add that as a node inside of one of the main scenes of our game. So before we get to setting everything up, let's go to demo and just take a quick look at what things will look like when we're done. So in demo top down, we can open up building system demo.tscn, and we should be able to see a simple working demo with art by OX72. So looking at the scene hierarchy, I have my systems up here at the top, the grid building system, grid targeting system, and an optional grid overlay drawer component under the building system. That's what gives it a colored grid overlay when you are in building preview mode. We have the game world with the tile map, which has to be referenced by these systems for things to work. And then we have a bunch of template UI that's basically just using default Godot graphics, but is helpful for testing out the functionality of these systems. So let's jump into this demo scene really quick, and we can see that we have a list of placeable objects over here on the right to select from. They can be categorized using tags, which we'll talk about later, and we can select one of these, which is going to call set building preview on the building system, which triggers building preview mode. So in building preview mode, we'll get an instance of the packed scene, which we want to instantiate into the game. Now, when it's in the preview mode, there's no collisions, so we're just getting a overlay display, really. But each of these little B squares that you see are tile collision indicators. So for those, they'll basically cast underneath and see if you get a collision against the existing game world and tile map. And if so, they'll turn color so that you know that there would be a collision. Now, a collision is actually one of the building rules that you can add to either your building system or individual placeable objects. Now, for most games, that's just going to be set as a always rule on the building system, just to make sure that you can't place anything if there's a collision. Now, if you need a rule to be object specific, then you would place that in the placeable resource file, and we'll show how to do that later. So if I hit enter here, then you'll see we get two failed messages in the build log. We get failed check due to placement collisions and tried placing outside of the valid map area. So that's another rule you can set up, and I would just include that in always rules typically. So that is the rule for checking if it's within the tile map bounds. So if we take the building system, I can check which rules I've set up and always include rules here. So we have a no collisions rule and a within tile map bounds rule. These are just embedded resources. You can expand them. And if you want to set a rule, you can click here, choose one of the defaults, or what you can do is you can extend building rule and create your own validation rules for the building system in your own projects. So back in the game preview, by default, if I press enter the UI accept action, then we will place an object into the game world if it passes all requirements. So I've set up another rule that are specific to the smithy object, which is that it requires the spending of gold resources indicated in the top left in this simple resource display up here. So if we didn't have enough resources, then it would fail out as well. So if I open up the build menu again, we can see that other objects like a gigantic egg can have different settings for their spend rules. So this egg costs 100 gold. And if we go back to the first tab, concave test object, this one actually has no spend rule whatsoever. So it only needs to meet the always include rules of the no collision rule and within tile map bound. So I'm going to go ahead and set up a tile map with some basic tiles so that we can use that to add the building system to it from scratch and show you how to set everything up for your own game. So if you're interested, I'm going to be using this pixel art pack, which is from Kanos at itch.io. I'll put a link in the description. And notably, this is actually 32 by 32 pixels. So still top down, so it should work with the grid building system. but I'll need to make a couple changes in order to scale things up to 32 by 32. But it should really just take a couple of steps. Okay, so to save some time, I went ahead and created a simple tile map. I'm going to just enable visible collision shapes here for a second, just so that you can see where the collision shapes happen to be. So these walls are set up to have collision, but the top bit is actually not. So theoretically, we should be able to build onto these top tiles, at least by default, and then onto the grass areas as well. Later, what I'll do is I'll also show you how to make a tile unplaceable, even if it's technically not on the main collision layer. So rather than adding the systems directly to the game level, we would want to be a little bit more flexible than that. So if your game has multiple game levels, you would want the ability to load up a new game level and then assign a new tile map using some of your other scripts. So rather than adding it to the game level scene, because that might get unloaded, let's create a new scene. I'm going to call it other node, and let's do a node, and we'll just call this gameplay. So I'll save this as a new scene in the root of my project. You can see I have art, which is just the art files I brought in from that Canos Pixel art top-down pack, and then the levels, which you just saw there. So I'm going to save the main gameplay scene in the root of my project. So this would basically be the scene you'd load up after the menu screen for your project, where you're playing the game. So inside of here, we're going to need to add a copy of our game level. So there's different ways you can do that. The most basic would just be to drag and drop the scene into gameplay. So we load up gameplay, it's just going to load up into this initial game level. And then we want to add in the building system and the grid targeting system at a minimum. So I'm going to right click, add a child node, and we're going to look for those two systems. So grid targeting system, we'll add that in. And then right click here, we'll also add in the building system. So the third thing we're going to want is going to be the positioner. So the positioner can really just be any 2D node, but I do have a template you can use from the demo. So if I just search for positioner here, gridpositioner.tscn, you can either use this one, copy it into your main project, or whatever you want. But let's just add a copy into here. So I'm not going to put it inside of the game level. It's going to be basically adjacent to the game level. So I'm going to want another node to group those together. So I'm going to right click on gameplay, and let's add in a node 2D. I'll call this world, and then we'll bring game level into here and grid positioner into here. So if we take a look at the grid positioner scene, it's pretty straightforward. It's just a 2D node that's going to have a position, and then we have the grid targeter here, which is just a looped animation for showing which tile we're hovering over. Now, by default, the grid positioner is set up for 16 by 16 pixel tiles. So if we use that with our game, which is actually on 32 by 32 pixel tiles, then it's going to look too small, but we'll fix that in a bit. So let's go back to our main scene here, and the grid targeting scene and the building system are going to have some external dependencies. So it's up to you how you want to assign these to your node. You could assign them when you load up your main gameplay script, and then find the systems and add in these dependencies. Or if you have everything loaded up into your main scene, like we're doing here, might be the case, then you can directly assign them inside of the editor. So the positioner is just going to be a 2D node that you want to have the grid targeting system move around the screen. It's going to snap to the center of each tile. So we'll assign that. And then the tile map is going to be, of course, where we're interacting with the tile map, which has tiles, which we want to snap to. So in order to get the tiles out of this game level scene, which you can see that we've saved the scene inside of our project, we can right click on game level and then do editable children so that we can get access to that. It's one way to do it. So as long as we can see the tile map, then we can easily assign it here in the inspector. So assign the tile map. Building system also needs to know about the tile map. So it doesn't directly need to know about the grid targeting system, but the grid targeting system is how we move that position to. And then place objects parent. Technically not required, but I would recommend it. Basically, whenever you place an object into the game world, it's going to go under this node. So we might have a group for objects inside of the game level, or we can just select the game level itself. So if we add it to the game level, then that means this game level is going to have a bunch of children objects that we just place into it. Technically works. And then next up we have the user node, which is a node in your game which is considered to be in control of the building system. So if you would think about it like a character going into a shop, and then that shop has a user interface. So the user is the person who walked into the shop. So same kind of thing with the building system. The person who would be spending resources in the building system is the user node that you want to assign here. So you could use a character body 2D that has an inventory under it, but some games won't have a basic character body. They might be more like a SimCity type game where the player is actually more of just a kind of like God overview figure. So if you're going to be using the spending rules, then as long as the user has a item container inside of it, you should be able to use that as your user node. So in the demo, I used the character body 2D, which contains all the other components like the inventory. But here, I'll just demo by creating just a random node. So let's add a new child node to the gameplay scene. So we'll do a node. I'm going to rename this to be player user, I suppose. And then we'll click on building system and assign that player user node. So for right now, we don't need the player user to have anything, but when we use the spend rules, we'll need some kind of inventory inside of it. So next up in settings, we're going to need to create a placement validator option. To do that, just click on the drop down and click here. So this is just a resource that will validate the building rules that you have set either up in always include rules in here or in each placeable object. And you can see there's some basic succeed or fail messages that it will output on success or fail, and you can respond to those with other UI like a build log. Aside from that, we need a collision indicator template. So if we search the project for indicator, we can see that I have the base template for 16 by 16 pixel grids. Now this is actually a 32 by 32 pixel tile set we're working on, so we'll need to scale the indicator up for that. And then the top-down demo project is using its own instantiated copy of this scene. So if you're going to be using this for your own project, what I would probably do is either copy this to your own main directory and then build from there, or you could instantiate a copy of the scene. So if you instantiate a copy, it's dependent on the scene, but any changes will also be inherited in the future. So that might be what you want to work with. So if you right click on tile collision indicator 16 by 16 and you do new inherited scene, then we can just go in here and change settings for our project. So if we click on the tile collision indicator, you can see that the collision mask by default is layer 1. So I guess I've already named layers 1 and 10. So I'm going to use the 10 as a placement collision layer. So there's not actually going to be collision on the placement layer. But what we want to do is that when we're doing the placement layer, we make sure that nothing is actually under those positions on the grid tile indicators. So by toggling placement, we can include shapes that are placement only collision shapes. And then for main collisions, we can use layer 1, ground, or whatever you want to call it, main collision. Those should be the layers that your player characters, your NPCs, are actually going to be colliding with, running into walls, and that kind of thing. So having two separate layers lets you separate those functions out. Now I'm going to save this inherited scene to the project. So let's put it under a new folder. So let's put this under a new folder. I'll put it in UI for right now, since the tile indicator is more of a UI component than a real collision object, though it does check for collisions. So I'll rename this and I'll call it tile collision indicator 32 by 32 tutorial. Just something that makes sense for you. So let's save that in there. And then if we jump into this new scene, I guess we're already in it, we can just zoom in all the way. So the default sprites I included are for 16 by 16 tiles. So if we want this to be the full size, then what we're going to want to do is to scale everything up. So if we go to transform and we do the scale to 2, then that's going to double the size of the tile collision indicator. Let's just make sure jumping into the shape that if we hide the collision shape, that it actually matches the rough size of our sprite. Okay, so now we can go ahead and save that scene. We'll go back to our main gameplay scene, and we will assign that indicator to the settings in the building system. So quick load, I'll search indicator, and we want the 32 by 32. So back in the gameplay scene, we want to assign that collision tile indicator. I guess somehow I have an extra one in the project. I'm just going to delete that out. And we're going to assign it to the collision tile indicator over here. So quick load, I'm going to search for indicator, and we have the UI/tile collision indicator. So we're going to open that up, and that should be assigned there. So now that we have the targeting system to move the positioner around and snap to the grid, the building system, for actually building objects, and the grid positioner added into the game world, we should be able to target the grid. So I'm going to hit play on this current scene. So that's F6, or over here, play the edited scene. So let's go ahead and hit play on the current scene, and you can see that we can target the squares on our grid. However, the grid positioner is still at its 16 by 16 scale ratio. So we're snapping to 32 pixel grids, but the indicator is too small here. So we just need to scale that up as well. So I'm going to search for the grid positioner, and I'm also going to right click here and do a new inherited scene for that. So we'll save this into the UI folder, and I'll just call this 32 by 32, hit save. And what we need to do is to scale up our grid targeter to basically double the size. So let's do that. I'll just hit 2 for scale, and that should work for right now. And now we want to change out the small grid positioner for the bigger version. So let's bring that into the game world scene. Just make sure it's parented under world. Okay, maybe it's easier if I put it up there. Okay, and we can delete the smaller grid positioner. And I guess I'll just rename this new grid positioner underscore 32, just so we know its size. Now we need to assign the new positioner to the building system and the grid targeting system. So let's just drag and drop those. Okay, now if we hit play, we should have the correct size for our tiles, and that is looking correct. So we have the positioning working, but we want to actually add in the ability to build with our build system. So to trigger build mode, what you're going to need is to set the buildable preview on the building system. So that is going to take a placeable resource, which is a class type defined in the plugin. And as long as you assign that to the buildable system, it'll enter building preview mode. And from there, you can use the input actions defined in the building system down here, the build action name, to actually try to build that object into the game world. And where it's going to place is into the placed object parent, which right now is being set to the game level, but any 2D node will work. Okay, so for that to work, we're going to need some kind of UI, either a button that can assign the placeable to the building system, or a tab container with a list view. So in the demo project, there's already several of those kind of classes, so we can create a little UI for our gameplay scene. Let's add a canvas layer to be the parent. And then under that, I'm just going to drag and drop some of the demo UI. So we'll just start with that for testing. Let's go into the demo UI. So a simple option, the build button test. If I look into here, you can see that this can assign a placeable to the building system. And it does that by doing set buildable preview on the building system. So that's really how you trigger the building system to start working. But then I also have this placement selection UI template. So we can drag this into the canvas layer. Okay, so for this placeable selection UI, I'm going to go up to the top, and just for testing purposes, we're just going to check show at start so that when we hit play, it's actually going to show our selection UI over here at the right. So we might make this a little bit smaller, or what we could do is increase the resolution of the screen. So let's try that first. Let's go up to project window settings, and let's make this a little bit bigger. Something like 1440 by 800 should be good. And if we hit play, then we should be able to work with that a little bit better. Alternatively, if you like, you can shrink some of the anchor points. So if we bring this in a little bit and maybe shrink the bottom, then that can be fine, as long as it's somewhere reasonable on the screen. So there's nothing inside of here right now because it needs some placeables added to it. So in the inspector, we can see that it can take an array of placeables here. And you can also categorize those placeables by assigning categorical tags. At the top here, we can also assign a action which can open the placeable selection interface. So I actually want to create that right now. That'll make it easy to open up our build inventory. So let's go to project settings, input, and we'll create a new action. I'm just going to call this build menu, add, and I'm going to assign the key B to it. So if you just, when it says listening, if you press B, it's going to give you B. So now the B on the keyboard will open up the build menu as soon as we assign it in open actions. So we just need to give it the string name. So that was build menu. Now we can do show at start turned off. If we hit run scene and B, well, we can toggle on the menu now. Okay, in external nodes, we also want to assign the build system. So when we select an option from the placeable selection, we of course need to tell the build system to actually set the buildable preview. So just assign the build system from the scene. So now let's go ahead and create some placeable objects for our game. I'm going to right click in the main folder and let's create a new objects folder. Inside of objects, I'm going to right click, create new placeables or placeable. Okay, so when we have a placeable resource file, I'm going to put it in here. And then the main object scene, what you actually instantiate into the game, will be somewhere in this objects folder. So first, let's build the actual object scene. So I'm going to right click here, do a new scene. We'll start with a 2D node, and I'll just call this test object.tscn. Okay. So the first thing we're going to need here is to actually grab a sprite for whatever object we're making. So I'll look into some of my art assets, and let's add a sprite node to the test object. So I'm going to right click, add child node, sprite 2D. And I think props sounds good. So let's do on texture over on the right, a new atlas texture. And I'm going to drag props into here. So now we need to select a region from the sprite sheet in order to select which object we're actually putting in the game. So it seems like there's some pretty decent ones here. We want to snap mode grid snap. And the grid, well, we could do 32 by 32 because it's a 32 by 32 tile set. So that looks like it'll be easiest. So let's see, what would we like to add to our game here? So let's start with the rock object over here. So I'm going to select the region for the rock. Okay, if we hit close now, then we have our rock sprite. So our rock sprite, we're going to want it to be a physical object, something that can be collided with, and we're going to need to give it a collision shape. So let's right click on the test object. I'm going to change that to a static body 2D. Okay, now static body 2D for physics to work, we need a collision shape. So let's right click, collision shape 2D. And I'm going to hit new shape, and we'll do, I guess, we'll try a capsule shape first. Okay, so if I hit Q to go into selection mode, we can adjust the shape and direction of our capsule. So if we go into the transform, we can rotate our capsule 90 degrees. Okay, that's looking a little better. So another thing I've been doing is positioning my sprites where the center at 0, 0 is where I want the sort point to be for Y sorting, which is pretty important for top-down games like this. So I'm going to hit W on sprite and collision shape with them both selected, and we're just going to move them up until I have basically that Y sort point. So it can be something like that. Okay, another thing we're going to want to keep in mind is the grid we're snapping to. So if we enable grid snapping mode, let's go into configure snap with this drop-down menu. I'm going to have grid step 16 and 16 here, but primary is every 2. So we're working on a 32 by 32 tile map, so the primary line is where the actual tile lines are drawn. So if I hit OK here, we'll be able to see these blocky squares, so we can get an idea of where our tiles actually are. But another thing that we want in configure snap is to offset by half of the size of the tiles. So 16 by 16 here, hit OK. Okay, and then we can see here around 0, 0. 0, 0 is our snap point, and then this will be the main first tile. So inside of this tile, if there is a collision shape that matches the collisions on our tile collision indicator, it's going to create a tile collision indicator during build preview mode. So we'll have one over here, up here, up here, up here, and down here. If you don't want it to take that many tiles, what you can do is just adjust your collision shape to make sure that it's within, like, let's say these bottom 3 tiles. So if I move the collision shape down here and we shrink it, I'll hit Q for that kind of selection mode, then now it should not have a tile collision indicator for these top 3 tiles. And that might be a little bit better for you, especially if you want it to be more closely aligned to the grid itself. Okay, so let's hit save there. So as long as you design with your tile grid sizes in mind, you'll get more of the desired result for your tile collision indicators. Now that should do just fine for here. And I guess for this object, we don't really need a separate placement area, although we could add another collision shape that's just for that. But what we do want to make sure for the test object is that the collision mode is set to our main collision area. So collision layer 1, so this will be an actual physical collision shape. If we wanted a placement only shape, then we would use the placement layer, which I was defaulting that to 10. You can use whatever you want as long as it is set up in your collision tile indicator to mask the placement layer. then you should be good to go. Okay, now that we have that object, we can create our placeable. So in the placeable objects, I'm going to right click here, create a new resource, search for placeable.gd, and we'll add that in. So we want this to be basically the same name of our main object. So I'll call this placeable big rock.tres. Okay, and then this test object scene, I'm going to rename that to be placeable big rock as well. And we'll rename this test object to be big rock. Okay. Now, in this placeable big rock TRES, we want to give it the packed scene. So that's just what we set up here, this placeable big rock.tscn. Drag that into placeable scene. So then we need to fill in the other fields for the placeable, the display name. When the placeable is showing up in a UI, how do you want it to be represented? So I'll give it the string big rock. So for the icon, the way that the tab container works in Godot out of the box is that it is not going to automatically scale the texture you provide. So if you use a full-size texture, then it may look way too big in the UI. So you may want to provide a smaller icon version of the big rock scene that you're going to be creating. So if we have something like that inside of here that we can use, then I would. But I don't think this is really like an icon pack. So maybe what we can actually use is one of those smaller rocks as the icon. That should help. So for the icon, I'm going to add a new texture. Let's do an Atlas texture. And I'll go into props. So we need to get that region, and we'll just get this 32 by 32 pixel texture. You can decide how big your icon should be for your game, for your UI. I'll just be using that. Okay, and then we can tag our placeable with any resource we want. So if we want it to work specifically with my demo UI, then we want that to be a categorical tag, but obviously it doesn't have to be a categorical tag. So the way that just works is if there is a matching resource file assigned to the placeable and assigned to the tab container, then it's going to put the placeable inside of that tab container. So somewhere in the project, I'm going to create a folder for those types of tags. Let's go in Placeable, and I'll create a new folder. I'll just call this tags here. And then I'm going to right click into here and create a new resource. I'm going to make that categorical tag. So that is going to be, let's just say, props tag. Or let's call it categorical tag props. So if we open that up, you'll see that the only real difference between the categorical tag and any random resource file is that it has an icon assigned here and a display name. So the display name can be props, and the icon, we can just assign one prop texture from that same props pack. So let's go find a texture for that. And this is a Atlas texture, so we're going to drag the sprite sheet in here, edit region, and grab whatever you want to use for props. Maybe I'll use this chest icon up here at the top. Okay, so if possible, I'd like to crop this top bit out. So I'm going to try assigning -30 to the Y margin and -30 to the H as well. Let me see if I can adjust that a little bit. Okay, -28. If it shows up like that, that would be good. So now that we have the tag, let's save that. And while we're working on this, I just want to point out, this is just a random demo UI. You can really create your UI to be however you want to work with the building system, as long as it calls set buildable preview on the buildable system. So this is just an example. Okay, so for categorical tag here, I'm going to add one, and we'll quick load it from the project. There's only one, so we'll do categorical tag props and assign that. Cool. Now we need to add placeables. So the placeable, we have the big rock. I'm going to drag that in here. So how this is going to work is that for each categorical tag, it'll add all the placeables that are added to this UI into each tag where there's a match. So a placeable could show up in multiple categories if it has multiple matching tags. So we run the scene. I'm going to hit B. We have the props categorical tag tab up here, but we don't have anything in the actual menu, and that is because I forgot to assign the tag to the placeable. So if we look at the placeable big rock, we just need to assign resources here to the tags. So categorical tag props will work there. So we'll tag that like that. Once again, you can use any resource you want to tag a prop with. Doesn't have to be resources, and you don't even have to use categorical tags if you don't want to. Okay, so now that we've added our placeable and category to the placeable selection UI, we can jump into the gameplay. So let's jump in here. If I click B to open the menu and we click on Big Rock, then we can see the 3 tile collision indicators in the 3 spots of our rock object where there was a collision shape on layer 1. So if I jump back into the scene, you should be able to see in this box, there's a collision over here, and here, there's one there and one there. So that's why we have 3 collision indicators for those 3 spots. Okay, so in the game, if we go here and we can start placing it around the scene, so I'm going to hit enter. Now you'll see that once that object is there, we have another collision shape into here as well. But right now we'd actually be able to place even if there is a collision. So if I hit enter right here, we're going to get another object there and another object here. So I can basically place anywhere I want, even on these walls that have collision shapes. And that's because we haven't added any building rules to the system yet. So relatively quick to set up. If we go to building system, we can use always include rules to set that up. So I'm going to add 2 here, and I think most people would want this as well. So in the rules, we have no collisions rule. So just add that in as a default. Don't need to do anything to it. And then on the next rule within Tilemap bounds rule as well, don't need to do anything to it. You can customize the failed and success messages here if you want to, but really this is just going to make it so that you can't put an object down if there's a collision, and you can't put an object down if it's outside of the Tilemap bounds. So let's hit play here, and let's do this again. So now I'm going to place an object, and then we try to place another object with enter, by the way. So I keep pressing enter and we don't get the object to place a bunch of times. We can't place it here as well, but we can place it anywhere where there's no collision. Okay, so to kind of demo the outside of the bounds, let's actually just erase some tiles. So if I erase a single tile right there, it's not going to have any tile data. So if we try to go over it, it is going to give the indicator for off grid. If I press enter, then you can see that it won't place as well. Now, we don't really have a lot of feedback right now about actually what's going on. So I'm going to actually add in the build log as well. So just another demo template you can use if you want to. So we put in the game log. I'm going to assign the build system so that we can get the signal callbacks on it. And then let's go into game mode. Okay, it's in the bottom left-hand corner by default, but I actually will position that to the bottom left. So if we click on game log, let's go to layout anchors, and let's take the right anchor to something like 0.4 and the left anchor to 0.2 or so. Okay, now let's hit run, and our build log's in the bottom left. It's kind of big though, so I'm actually going to shrink the top anchor as well. The reason for using anchors instead of just position is anchors scale with your game. So if you have a full resolution like 1920 by 1080 pixels, then it would scale up to that resolution. Okay, now that we have that build log, we can place objects into the scene. We have successfully built a big rock there, and this is going to fail due to placement collisions. This is going to fail due to being outside the map area. All right, so that is the basics, but we may also want to have spending resources as a rule. So this rock might cost some kind of resource. So to set that up, we want to go access our placeable. So we have our placeable big rock, and let's add in a build rule here. So now in this array of build rules, we want to click here and go to new spendable materials rule. There's also new spendable materials rule generic. If you don't want to use the base classes I've included for the item container or the item container example itself, then you can use generic instead, which just means that the node that contains your inventory class is going to need to implement certain methods, like an interface in C#. So let's go ahead and do new spend rules. I'll just use the default inventory that I've provided in this plugin. So in the spend materials rule, we're going to need to give it one or more item stacks. So each of these item stacks is going to contain a type and a count. So the type here in this non-generic version is any resource that implements base item. So rather than creating a new one embedded right here, we want to create a item in our project. So in the file system, let's go to the top of our system here and create a new folder for items or materials. And inside of the items, let's create a new resource. So I'll just do base item. So generally what you'd probably do is you would extend from base item. So let's right click into items, go to new resource and search for base item. So I'm going to create the resource as it is, and let's call it item test for right now and hit save. So yeah, generally what you would do is you would extend this to create your own specific requirements for different types of items in your game. And then this would just have some of the bases. So for instance, a display name, a texture that you want to display for the item, a tags, just like tagging placeables. You can put any resource here to mark the item to be of a certain type. And then stack maximum when you have an item in an inventory. How many of them can you have at once? So let's go ahead and grab a texture that we could use for an item. So I'm going to click here and do a Atlas texture, and I'll use the props from this pack to find some image that might work for a item texture. So if I hit edit region, we can go grab something. So what could be a spendable item? I'm thinking we could have like rock points, or maybe a chest could represent something like build points. Let's go with the rock, and I'll call this like a rock resource. Okay, so now that we have the texture, let's minimize that. And then the display name, we'll call it stone. To create a tag, I'll right click in items, do a new folder, and let's call this tags. So this will be for item tags. So I want a tag for materials. So I'll do create new resource categorical tag, and let's call this tag material. Okay, so now we have this tag resource. I can give that a name. Eventually maybe set an icon for that if I need to as well. And for right now, I'll just take the tag material and I'll assign that to this item. Okay, so now we have items that are of a material type. So one of the things you can do with the item container class I provided, which once again is completely optional, it's only really for using the non-generic spend materials rule class. You can use the generic version of spend materials, or you can create your own version of spend materials if you'd like. As long as it inherits from building material, it should work with the system. You just need to create a validation method. But if you're using the out-of-the-box item container class, then we can filter what can go into a container by having tags like material tags. So to create a material item container, you would just have it only allow items with a material tag. And then stack maximum, let's give it a maximum of 10,000. Sure. That seems fine. So what we want to do in our placeable big rock is make it now so that we need an item stack of stone of a certain amount in order to spend that resource to place the rock object into the game worlds. Okay, so now that we have our item resource, we want to assign that to the Placeables spend rule. So let's click on placeablebigrock.tres, and we have our spend materials rule. So we have the item stack, which is going to take an item type. So this needs to be a base item in the default spend rule anyway. So I'm going to take item test, and we're going to put that in there for the type. So as long as it's base item, we can spend it here. You can expand it and see the details about that resource. And then we need to say how much. So let's say that it takes 10 stone in order to craft a big placeable rock. Okay, so now what's going to happen is that we have to pass the spend materials rule in order to place the object into the game world, which means that the user is going to need to have an item container in order to have materials in that container to spend. Before that, let's go ahead and rename this item test to item stone. That would be more appropriate here. So I'm going to find the resource file, and I'm going to rename it to be item stone. Or it could even be material stone if you want to be a little bit more specific. Yeah, let's go ahead and call it material stone. So we have the player user node inside of our main scene hierarchy. So like I mentioned before, this could be easily a character body 2D that just happens to have an inventory item container node inside of it. But it doesn't have to be. So we'll just use this standard node. I'll add a child node, and we're going to look for item container. The user could even just directly be the item container if you want it to be targeted that way. So the item container, we can put allowed tags if we want to limit what can and can't be put into the container, or we can just have an item container that supports anything like a generic inventory. And here we can set up what is in the container by default. So I'm going to add a base item stack, and let's give it a new item stack. For the item type, let's do a quick load on the material stone. And let's give it a resource count of We can say 100. Now if we run the current scene, we should be able to place 10 of those stone objects into the scene. So big rock, let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the last one, we fail because there's no more stone in the container left to spend. So without having any kind of visual indicator, it's a little hard to know exactly how much of a material is left in your container. So you can create your own UI for that. Or alternatively, if you want to use the demo, you can just go ahead and do a resource. You can search the project for resource display. So we'll just have one of these pop in here. And this is just like a really simple demo UI. But if we connect this to either the player user or the item container, I'll just get the item container directly here, then we should be able to display the resources that are in the container and a little UI. And so for the resources display, we'll want to assign which node has the item container. So we'll do the player user, and I'm going to run the current scene. Now, right now, it's only splitting this space into one column, which is a little bit too wide. So what you could do is just right-click on this, editable children, and then we go down to the grid container, and I'll add in some extra columns here. So that'll make your resources space out a little bit more evenly for each resource. Okay, so now if we spend the resources like this, 1, 2, 3, 4, 5, 6, you can see that the item container is losing its stone as time goes on. And having it remove the resource completely from this display is optional. If we go up to the top here, you can just toggle off remove zero count display. And now while we do it, the resource will always be there, even if it hits a count of 0. So that's pretty much going to be it for this initial walkthrough on the grid building system. So if you have any questions, comments, or features you'd like to see, feel free to leave a comment either on the video or on my itch.io page or Ko-Fi, wherever you can reach me. You can actually just check my link tree for all my links. So with that, I've been Chris. Thanks for watching to the end, and hopefully I'll see all of you in my future Godot video content.